Hi everybody, it's Mrs. Ilbring. Here's your video review for the study guide. Please open to page 20. Which of the following relations is not a function? So in order for something to be a function, the x values cannot repeat. So you're looking through the choices here, which is the only one where x values don't repeat. Oh, which is the only one where we're looking for not a function. So which is the only one that has x values that do repeat? So just look at the x's. 2, 4, 6, 8. We're good. 2, 4, 6, 8. We're good. 2, 4, 6, 2. That's the problem. So choice E is not a function. When looking at a graph, what we're looking for a function is a function must pass the vertical line test. So let's read the question. Which diagram represents a relation in which each member of the domain corresponds to only one member of its range? That's the definition of a function. Our letters are below, but it's D. This is the only one that passes the vertical line test. And let's look at the same idea in a table. Which of the following represents a function? There can be more than one answer. Okay, for it to be a function, again, x values cannot repeat. 1, 2, 3, 4. We're good. -2, 2, and 2. No good. 1, 2, -1, -2. We're good. Which statement is true? Number 4, and turn to page 21. Which statement is true about the relation shown on the graph below? So, is this a function? That's the first question. Does it pass vertical line test? It doesn't. This one fails vertical line test. So, we can cross off A and C. This one is not a function. When you think about the vertical line test, the issue is that at some x value, there are 2 y values. So if we look at choice B, there are multiple, it's just backwards, but there are multiple y values for an x value. Let me see if I can just move this over a little bit. So if I think where 5 is, I've got 5, and I think that's at 3. And then I've got 5, -5. The problem is when x is 5, there's more than one y value. So C is your answer. There is actually a typo on this problem, so let me go through what the answer is, and then what the problem is, then we'll look at the choices. The accompanying graph models the height in feet of a car and a roller coaster based on time in seconds. Domain is the x values. So when we look at the graph, where are my x values going? Well, they're starting at 0 and going all the way to 180. That's a 3-minute roller coaster ride. I think there's a typo in this one, and I think that this should be 0 instead of 20. We're going to call this choice A. Domain has to do with the x values, so it's not C and D. And then for B, that doesn't really make any sense. So like I said, I think we just had a typo on that one. Okay, turn the page to the next page, which is actually not labeled, so it's page 22. Which graph below would match the situation described? So let's see. A car traveling at 23 miles per hour for 5 seconds. That means we're starting off at a steady speed. We're not starting from 0. It accelerates to 50 miles per hour, and then it maintains that speed for another 5 seconds. So the only one that describes that well, we're going a steady speed, we accelerate, then we go another steady speed. So this would be choice D. The table below shows the yearly sales of a luggage set in a particular store. Find an equation for the relation. Remember, we want to have our starting point, and then we want to see what are we going up by. Can we find a pattern? So we can. We're going up by 25 every time. So remember, start at 15, up by 25. And how many 25s did we add? Well, it's one less than this number. So our equation is 15 plus 25, and then n minus 1. Given the sequence, -8, -17, -26, and -35. Explain whether or not the sequence is arithmetic. If so, state the common difference. So what we're looking for is, does this go up or down by the same number? And this one does. It goes down by 9. So this would be yes. And the common difference is -9. Next 3 terms, well, just keep subtracting 9. -4, -53, -62. Write an equation for the nth term. A sub n equals a sub 1 plus d times n minus 1. A sub 1 is your first term, that's -8. The difference was -9, and then n minus 1. The only other thing you have to do on these problems is distribute and simplify. So 9 minus 8 is 1, and this would be 1 minus 9n. I'm going to do the rest of the video, rest of the study guide in a second video. Hi everybody, this is day 2 of the study guide for the Algebra 1 test. Please open up your packets. It doesn't have a page number for whatever reason it didn't write down, but it would be page 23 if you numbered yourself. So first problem has to do with rate of change. In 2000, school lunch at East High was $1.20. In 2016, the cost increased to $2.60. I hope I said that right. Find the annual rate of change in the price for school lunch from 2000 to 2016. So remember, for years, we don't look at 2000 as a year. We look at that as the starting point. So it would be 0, 120. 2016 is 16 years later, and the price is now $2.60. From there, it's just a simple slope formula problem. I'm going to do the math for you. So lunch changed $1.40 in 16 years. And when you work that one out, it went up, we should say up, 8.75 cents per year. Whenever you're doing rate of change problems, make sure you write a label. Okay, find the slope that passes through the points 2, 1, and 3, negative 1. I don't think you guys need to do this, but if you need to, remember the 1 just stands for like a label. So this is the first point, this is the second point. Slope formula, y2 minus y1 over x2 minus x1. Negative 1 minus 1 over 3 minus 2. That's it. Number 11, we can just use the formula up above. 3 minus negative 2 over negative 4 minus negative 5. Again, just be careful with your signs. Slope is 5 over 1. When we look at slopes of graphs, remember we're using rise over run. So what you need to do, I'll get a red so we can see it. You're looking for a point where it goes through like an intersection really well. So this is the point, and here's another good one. This slope, it's going downhill, so it's negative. And then rise over run is how much up, how much over. Up 3, over 2. That's it. So I know in my class, I didn't go over this, so we'll go over it now. If you look at 2 points, let's say this is 3, 1, and this is 3, 3. If we figure out slope, it would be 3 minus 1 over 3 minus 3. We did do this part. You can't have 0 in the denominator. This slope is undefined. Now, I did not do this problem in my class, but I will go through it anyway in case you're in a different class. Find the value of r in these 2 points so that the slope of the line containing them is negative 1/2. So what I'm going to do is fill in the slope formula with what I have. Negative 1 over 2 equals, I'm going to start here, 4 minus r over r minus 5. Best way to solve this is to cross multiply. That's a negative 1. It just got a little diagonal. Negative 1 times r minus 5 equals 2 times 4 minus r. And if you solve this, I'm going to add 2r to both sides. I'm going to subtract 5 from both sides. And I got r equals 3. Justify the steps. We set up the slope formula. And you solved for r. Let's flip the page. This would be page 24, even though it doesn't have a number at the end. The hardest part about this problem is that the print is a little bit light, and it's also a little bit tight together. So what I'm going to do is I'm going to mark every 2. I'm going to mark every 2. And I'm going to mark every 2 going up as well. And you can't see me, but I'm really like looking closely at the monitor here. When you have points, that's when you write domain in the brackets, and you're just listing every x value. So if I start from the lowest, this would be negative 6. See, this is where my little markers come in handy. Negative 6, negative 4, 0, 2. Then let's see, here we're at 6 and 8. we're going to do the same thing for the range. I'm going to go from the bottom to the top. So this is -5. We're at 3. We're at 6. And we're at 7. So is this a function? A couple ways to tell. One way is that none of the x values repeat. The other way, if I went ahead and made a vertical, gosh, it would help if I made the line vertical. If I go ahead and make a vertical line, will my line ever touch in more than one spot? Nope, we're good. So this is yes, and you could give either of those reasons. Passes the vertical line test. You could say x values do not repeat. Either of those would be fine. This is really going to be up to you. Use the graph below to answer the following questions. Write a real-world situation. So whatever you do, I suggest that your x value is time. I'm going to use our good old standby altitude. And you could put numbers here, or you could leave them blank. So I'm going to put numbers here just to say like portions of the graph. So part 1 could be the plane takes off. Part 2 would be the plane cruises at steady altitude. That means it's like not going up or down. And then part 3 would be plane climbs higher. Okay, there's lots of different versions of this that you can have for the story. Okay, part B, label the x and y axis. Well, I did that. I put time and altitude. I guess I could put feet. You know, put an actual unit. Independent and dependent. Remember, independent's always the x, so that's time. And dependent is whatever you put for your y value, and that's altitude. Okay, let's flip over to our last page. This is a big page, but it only takes a minute. And I moved things around a little bit to try to get it on one page. Create a mapping. Mapping is when we have these two ovals. And trust me, I'm not judging you on the quality of your ovals. And all you're doing is connecting. So like 4 goes to -2. 1 goes to -4. 3 goes to 7. -1 goes to 6. Now, I said in my class, if any of you get this table wrong, I'm quitting my job. Okay, create a table. You can really handle this. 4, -2. That's it. Just put it in a table form. 1, -4. 3, 7. -1, 6. Create a graph. I think you guys know how to graph too, and this is nicely labeled. I'll go in blue. 4, -2. 1, -4. 3, 7. -1, 6. Is it a function? Yes. The x's don't repeat. It passes the vertical line test. Both of those would be fine. And write the inverse. Just switch x and y. Okay, good luck on your test.